So here's a quick video on reviewing what we've been doing these last few days, which is section 10.2 and 10.3. So let's start off by doing this problem together. Let's simplify the radical of the square root of 27. So remember, when we're doing a square root, we want to start breaking it down by thinking about what are numbers that multiply to 27, and we're looking for pairs. So if I start this factor tree, two numbers that multiply to 27 would be 9 and 3. 9 is a number that we can keep breaking up. It's not what we call prime. So I know that I'm going to be able to extend it further. But the number 3, the only way to multiply to 3 is 1 times 3. So that means that that number is what we call prime. I'm going to circle it, which tells me that that branch is dead. I can't expand on that any further. How we multiply to 9 would be 3 times 3. Once again, those are what we call prime numbers. So I circled them. Because everything now is circled and I can't extend those branches any further, that tells me that I'm done making my factor tree. And so then essentially I'm going to count up everything that's circled and put them back underneath that square root. So there's 3 numbers that are circled. So really 3 times 3 times 3 multiplies and gets you back to that 27 that's under the square root. But like I mentioned, the whole point of a square root is I'm looking for pairs. So notice that here is 1 pair of 3s. Now there is an extra number, but there's nothing to pair it up with. Once I've noticed all of my pairs, that pair then moves to the outside. So that gets to move to the outside. So there's only 1 pair, so I write that number 1 time. The number that doesn't have a pair stays under the square root, and so 3 root 3 would be my final answer. So now I want you to pause the video and see if you can simplify the square root of 112. So hopefully when you paused it, there's probably a lot of different ways that you could have broken up the 112. So I just started by knowing that it was an even number, so I know 2 went into it. So 2 times 56. 56 then is 7 times 8. 8 can go into 2 times 4, and then 4 is 2 times 2. So once again, once I have circled a number, I can't expand on that number any further. If you look at all the numbers that are circled, I've got 1, 2, 3, 4, 5 numbers that are circled. So I kept the same numbers together. So there were 4 2s and there was 1 7. Remember, the pairs get to move to the outside. So I had not just 1 pair of 2s, but I had 2 pairs. So 2 2s moved to the outside. The 7 didn't have a pair, it stayed underneath. Any numbers that move to the outside, you multiply them together. Any numbers that stay under the square root because there isn't a pair, those get multiplied together. So that's why my final answer was 4 root 7. Try another one. Notice this time I want you to simplify 3 root 72. So pause the video, see if you can do it. So it's just very, very similar to what we just did. You want to break down that square root of 72. But remember, when you start breaking them down and you're looking at all your numbers that are circled, not only do those numbers then stay under the square root, but you have to remember that there was an original 3 on the outside. So notice in my work, I brought that original 3 down, and then I took out the pairs that I had. Remember, any numbers that move to the outside get multiplied together. Once again, it just ended up where there was 1 number left over that didn't get paired up. That stayed under the square root. So when I multiply those numbers on the outside, it gives me 18. So 18 root 2 is my answer. All right, let's try this one together. Let's simplify 2 root 45 times 3 root 18. All right, so when you have this multiplication, what I'm going to do is I'm going to start off by doing my factor tree. So let's start with the 45. So 2 numbers that multiply to 45 would be 9 times 5. 5 is a number that I can't break down any further, so that gets circled. 9, I can break that up into 3 and 3. So that means that I'm going to have those numbers that are circled underneath the square root. The issue, or not really an issue, but what we understand is that because we are multiplying here, multiplying means that I'm going to start breaking up this next radical as well. And then anything that's circled, I get to put together underneath one big giant square root. So numbers that multiply to 18, there's several different ones, but one of them would be 6 times 3. I get to circle the 3 because it's prime. 6 is 2 times 3. Both of those are prime as well. All right, so notice that how I'm going to write this. The numbers that start on the outside, the 2 and the 3, I get to keep them on the outside, and they're being multiplied together because that's the operation that we're talking about. But then, like I said, underneath that big square root, notice that we've got 1, 2, 3, 4, 5, 6 numbers that are circled. So I see that there's a 2, and then there's no other 2s. There's 1, 2, 3, 4 3s. So I get to write all those. And then I see a 5. Once again, 1, 2, 3, 4, 5, 6 numbers that are circled. 1, 2, 3, 4, 5, 6 numbers that are under that square root. So I didn't miss a number. So now that I have it looking like this, I start looking for my pairs. We'll notice that there's not just one pair of 3s, there's 2 pairs of 3s. So my original numbers that were on the outside get to stay on the outside, being multiplied together. I now get to move 2 more numbers to the outside. Those are all going to get multiplied together. Under the square root, I still had 2 numbers. I've got this 2 and I've got this 5. Those are going to be multiplied underneath the square root. Okay, so now you can use your calculator. 2 times 3 times 3 times 3. That's going to give us the number 54. So that's the number that's on the outside. Underneath the square root, 2 times 5 is going to give us 10. So here is my final answer, 54 root 10. All right, now I want you to pause the video and see if you can multiply the square root of 7 times 6 root 14. All right, so notice that the 7 and the 14 are technically under the square root. So when I start breaking down these numbers, technically this first 7 is just going to get circled right away. It's not going to be able to get broken down because it's a prime number. 14 is 7 times 2. So notice that 7, 7, and 2 are under that square root, and there's only one number that started outside, which was the 6. So I get to move the 7 outside because there's one pair. 6 times 7 is 42, and the only number that didn't pair stays under the square root. So 42 root 2 is my answer. All right, same idea, but try this. Pause the video and see if you can multiply the square root of 5 times the square root of 8 times the square root of 16. All right, a couple different ways that you can think about this. Notice that 16 is actually what we call a perfect square. If you started breaking that down, one of the ways to multiply to 16 is 4 times 4. And right off the bat, there's a pair. So if you can think about those numbers in terms of a perfect square, it might make it a little bit easier when you're trying to then do your pairing up and moving to the outside. Notice that 5 gets to get circled right away, though, because it's a prime number. I can't break that down. 8 gets broken down into 4 times 2, which then 4 is 2 times 2. So notice that there are technically 4 numbers under the square root that are then prime numbers, and we only have one pair. So I get to move a pair of 2's to the outside. 4 times 2 gives me 8, and then 2 times 5 under the square root becomes 10. So 8 root 10. All right, let's simplify this. We've got 2 root 6 minus 18 root 6. So notice that the operation that we're dealing with this time is a subtraction sign. Remember, when you're adding or subtracting, you must have the same number under the square root. And luckily for us, I see a 6 in the first square root and a 6 in the second. So that means that we have like terms. So that means all I have to do in order to actually solve this problem is take the numbers that are out in front, which is the 2 and the 18. I'm going to subtract them. 2 minus 18 is going to give us a negative 16. And then I keep that same radical. So negative 16 root 6 would be my final answer. So as long as they have the same number under the square root, you just combine the numbers in front with whatever operation sign is in between, and then you keep that same radical. So now you try this one. We've got 12 root 3 plus the square root of 3. So don't forget, when you don't see a number in front of the square root, it's technically a 1. So I get to add 12 plus 1, which is why it's 13, and then you keep the square root of 3 as it is. All right, let's simplify this. We've got negative root 5 plus 4 root 80. So what I'm going to do is I'm actually going to write a negative 1 root 5 plus 4 root 80. Now, once again, if I'm looking at the sign, anytime I see an addition or a subtraction sign in between my two radicals, that means that, once again, you must have the same number under the square root. And right now, we do not. One of the numbers is a 5 and one of the numbers is an 80. So we have to try to get the same number underneath if we want to actually try to add these together. So remember, 5 is what we call a perfect square. I can't break up 5 into anything other than 1 times 5. So that means that that first square root, I get to keep that exactly like it is. So it's really the 80 that I want to start breaking up. So two numbers that multiply to 80. There's a lot of different options. One of them is 8 times 10. So then I can keep breaking both of those up. 8 is 4 times 2. I can circle the 2. I can keep going with the 4. 4 is 2 times 2. So now that all those numbers are circled, I'm done with that side. I can move over to the 10. 10 is 2 times 5. Both of those are prime numbers. All right, so remember, I get to keep that negative 1 root 5 as it is. Plus, I'm going to bring down that 4, but now underneath the square root, it's not 80, it's all of those numbers that are circled. So we have 2, 2, 2, 2, and 5, because there are 5 circled numbers. So notice that I start pairing them up. Looks like there's 2 pairs of the same number. So those get to move outside of the square root. So really outside we've got 4 times 2 times 2, and now we'll have that 5 under the square root. So once I multiply those numbers together, 4 times 2 times 2, that will give us 16. So really this problem is negative 1 root 5 plus 16 root 5. So now that they have the same number under the square root, I once again get to add the numbers in the front, so negative 1 plus 16. That's going to give me a positive 15, and I get to keep that square root of 5 as it is. And there is my answer. So now you try this one. Go ahead and simplify 3 root 8 minus 14 root 18. Okay, so hopefully you pause the video. Both of those had to be simplified because they were not the same number. 8 is not a prime number. Notice they get broken down into 2 times 2 times 2. So that means we move that to the outside. We have one pair. So 3 times 2 means that 6 is on the outside and a square root of 2 is after it. The 18 gets broken up. Several different ways you can break up the 18, but one of them is 9 times 2, and 9 is 3 times 3. So we have 3 numbers that are under the square root. I have one pair that gets to move to the outside. You get to multiply that by that negative 14. So that's why my final then problem is 6 root 2 minus 42 root 2. So notice how I get to subtract the numbers on the outside. 6 minus 42 gives you negative 36, and we get to now keep the square root of 2 after it. All right, so that was all what I wanted you to review. Hopefully that makes a little bit more sense. Reach out to me or Ms. Tolles if you have any questions.